problem. A linear system is described by the impulse response h of t is equal to 1 by RC e power minus t by RC u of t. Assume an input process whose ACF is b into delta t, delta tau. Find the mean and ACF of the output process. Given h of t is equal to 1 by RC e power minus t by RC u of t which is equal to 1 t greater than or equal to 0, 0 t less than 0. Applying in h of t becomes which is equal to 1 by RC e power minus t by RC t greater than or equal to 0, 0 t less than 0. This is equation number 1. We know h of omega which is equal to Fourier transform of small h of t is equal to by the definition of Fourier transform minus infinite to plus infinite h of t e power minus I omega t dt. That is equal to, we are splitting into two parts. First part negative part integral minus infinite to 0, and that part h of t is 0 by equation number 1, plus the positive part 0 to infinite, the value h of t value is 1 by RC e power minus t by RC because t greater than or equal to 0. So into e power minus I omega t dt, right? That is equal to 1 by RC integral 0 to infinite. 1 by RC is a constant. Taking 1 by RC outside from the integral, you will get is 1 by RC integral 0 to infinite e power minus 1 by RC plus I omega into t. T is a common term, take it outside, into dt, right? That is equal to 1 by RC e power minus ax formula, integral e power minus ax which is equal to e power minus ax by minus a. Instead of a, you are having 1 by RC plus I omega. So substituting, so you will get lower limit and upper limit 0 to infinite. Applying the upper limit e power minus infinite, we know 0, that first term becomes 0. E power minus 0 1, the second term minus of minus plus, so you will get 1 by RC 1 by RC plus I omega, that is the second term, right? So you will get 1 by RC into 1 by RC plus I omega. So now that is 1 by RC into a conjugate of 1 by RC plus I omega is 1 by RC minus I omega. We are multiplying that conjugate in the numerator and the denominator and grouping that 1 by RC minus I omega, and down in denominator we are using a plus b into a minus b. A is nothing but 1 by RC, b is nothing but I omega. So a square 1 by RC square plus I minus I omega square, I square minus 1 minus into minus plus, you will get plus omega square. So h of omega is nothing but 1 by RC minus I omega by 1 by RC square plus omega square. That is equation number 2. H star is conjugate of h. So h star is nothing but 1 by RC. So conjugate 1 by RC plus I omega, right? By 1 by RC square plus omega square. That is equation number 3. Now h modulus h omega square is equal to h into h star, right? Now multiplying 2 and 3, you will get 1 by RC into 1 by RC, 1 by RC square, right? First, in the numerator, 1 by RC minus I omega into 1 by RC plus omega. So a minus b into a plus b. So you will get again 1 by RC square plus omega square, correct? In denominator, so 1 by RC square plus omega square into 1 by RC square plus omega square. So you will get in denominator 1 by RC square plus omega square, the whole square. So cancelling one term, so you will get 1 by RC square into 1 by RC square plus omega square. That is equation number 4. We know power spectrum is the output, power spectrum of output Sy of y of omega which is equal to modulus h omega square Sxx of omega. Substituting these values 1 by RC square into 1 by RC square plus omega square into Sxx of omega. That is equation number 5. Now Rxx tau is given, that is equal to b into lambda tau. That is equation number 6. We know Sxx of omega is equal to Fourier transform of the Rxx of tau. So Fourier transform of b delta t, right? So b is a constant, take it outside, b into Fourier transform of delta t. Fourier transform of delta t is nothing but from the definition b into integral minus infinite to plus infinite delta tau e power minus I omega tau d tau. So that is equal to b into e power minus 0. that is equal to b. We know integral minus infinite to plus infinite f of tau delta tau d tau is equal to f of 0. Here f of tau is e power minus I omega tau. So e power 0 you will get 1, right? So that is b. So yes, xx of omega is equal to b. That is equation number 7. From 5 and 7, yes, yy of omega, which is equal to 1 by rc square 1 by 1 by rc square plus omega square into b. We know Fourier transform of autocorrelation r of tau is the power spectrum. So this is syy of omega can be written as Fourier transform of ryy of tau, which is equal to 1 by rc square into 1 by rc square plus omega square into b. So taking inverse Fourier transform of, so f inverse of f ryy of tau becomes ryy of tau in the left hand side. The right hand side f inverse of 1 by rc square into 1 by rc square plus omega square into b. Here b is a constant, 1 by rc square is a constant, take it outside. So b into 1 by rc square f inverse of 1 by rc square plus omega square in the right hand side. So applying inverse Fourier transform to 1 by rc square plus omega square. So that is equal to, we will f inverse Fourier transform, inverse Fourier transform definition. By the definition you will get 1 by 2 pi 1 by rc square into b 1 by 2 pi integral minus infinite to plus infinite 1 by rc square plus omega square e power I omega tau d omega. So 1 by 2 pi 1 by rc square into b, then integral value. So integral of minus infinite to plus infinite e power I omega t by omega square a square d omega, which is equal to pi by a e power minus a modulus tau, a which is equal to 1 by rc. So we are replacing that one. So you will get 1 by 2 pi 1 by rc square b into pi by 1 by rc e power minus 1 by rc modulus tau. So that is equal to b by 2 rc, pi and pi cancel, 1 by rc square 1 by rc cancel, you will get balance 1 by rc. So b by 2 rc e power minus 1 by rc modulus tau. Right, thanks. We'll see in the next video. Because of the time consumption, I'm going very fast. Right, thanks.